All right, we are live now. You can go ahead, Kumar.
Okay. So, on behalf of the entire Daily Power BI user group, I want to welcome our speaker for October, and he is none other than Chris Webb from Microsoft. Chris Webb needs no introduction, and people like us who have worked in Power BI have learned so much from his blogs, his videos. For the people who don't know, his blog comes under the name of crossjoin.co.uk. And apart from this, Chris helps the community in right now currently lots of articles on Fabric and Direct Lake and the Data Lake. So it's an amazing session that will happen today. I will, without much ado, I will hand it over to Chris.
Cool. Thank you. And thank you for inviting me. It's great to be here. So let me share my screen. Give me a thumbs up when you can see it.
Yep, you can see.
Great. Well, yes, I won't spend too much time introducing me, except that if you do want to find my blog, so let me share my screen. Give me a thumbs up when you can see it. Twitter as well.
Yep,
I work at
you can see.
Microsoft on something called the Fabric Customer Advisory I won't spend team. too much time introducing me. Well, I used to work on the Power BI Customer Advisory team, but we got merged and renamed to be the Fabric Customer Advisory team. And that, I think, is going to be significant for what I'm going to be talking about today, which is the topic of Power BI, Fabric, and your data lakehouse. So what will we be talking about? We'll talk a little bit about what a data lakehouse is. If you've got a data lakehouse already, or you're thinking about building one, then this is going to be a very relevant presentation for you. If you don't have a data lakehouse, don't worry. This is also going to be interesting because there will be a lot about Power BI and Fabric. And if you're wondering what Fabric is, we'll talk a little bit about that as well. But we'll talk about what changes if you're working with Power BI in a data lakehouse with Fabric, and what some of the really cool features of Fabric are. So first of all, let's address the obvious first question. What is a data lakehouse? While preparing the slide, I went and had a quick Google, or Bing maybe I should say, for resources, and unsurprisingly, the number one hit was from Databricks. Databricks is the company that popularized the idea of a data lakehouse. And I think this diagram really kind of sums things up well. When I first started working with data, everybody wanted to build a data warehouse. So you would take your data, you'd transform it, you'd load it into a relational database, SQL Server or something like that. And then you would build your analysis services cubes on top of it, or your reporting services reports, and so on. And that was great. Lots of people were very successful with data warehouses. The trouble is they were slow to build, they were expensive, they were inflexible. And as different types of data came online, it became harder and harder to load your data into a data warehouse. Then people came up with the idea of a data lake, a place where you could store all of your data in files, and then use a variety of different tools to get at that data and analyze it. Sometimes people loaded their data into a data warehouse afterwards. Sometimes data scientists would connect directly to the files in the lake and do their analysis in notebooks, do machine learning and things like that. The trouble with data lakes is that very quickly they turned into data swamps. They were unstructured. It was a bit of a free-for-all. And so people came up with the idea of a data lakehouse, which is kind of a combination of a data warehouse and a data lake, getting the best bits of both of them. From the data lake, you get the ability to store all different types of file in cheap storage and then separate the compute away. From the data warehouse, you get that metadata and governance layer and things like ACID transactions. So data lakehouse is a very popular term. Databricks coined the phrase. Other vendors have jumped on the bandwagon, and guess what? Now Microsoft is jumping on the data lakehouse bandwagon. So everybody likes the idea of having a lakehouse, which is a combination of the best bits of a data lake and a data warehouse. Now, A lot of people with data lakehouses, a lot of people using Azure Databricks, for example, want to do reporting in Power BI because notebooks are not really enough. You need to be able to get the data out to a large number of people so they can build their own reports or they can consume those reports. So what has been the approach up till now? This is a very, very, very typical architecture that I see when I talk to customers. You have your source data, you load the data into your data lake or your data lakehouse, which is typically ADLS Gen 2 storage. And then you want to get it into Power BI. But in between, you have a relational serving layer. And that could either be Synapse dedicated pools or Synapse serverless. That could be Azure SQL DB. If you're using Azure Databricks, you might have a Databricks SQL warehouse. You might be using Snowflake. You might be using BigQuery. But you've got this extra layer between the data in your data lake, your data lakehouse, and Power BI. So what is the point of this layer? Why do we need it? A couple of reasons. So first of all, if you've ever tried to connect Power BI up to files, you will know that if you're looking for lots and lots of files, it can be quite hard to do that. If you're looking for files in folders that you own, there could be quite a lot of clicking around. And if you want end users to go away and get data from files in a data lakehouse, it can be very, very difficult for people to find what they need and understand what's there. Because quite often you don't just see tables, you see folders full of files. And you've got to know that all of these files represent a single table, and you've got to be able to combine all of the data from all of these files into a table. So finding files is difficult. Connecting to files is difficult as well. Not only do you have to combine all the data in multiple files into a table, if you're connecting to ADLS Gen 2 storage, you've got to know, where endpoints are. You've got to get all the right permissions. You've got to know how to set all of the right properties on the ADLS Gen 2 connector, because if you don't do that, sometimes things can be very, very slow. It's all really, really nasty and complicated, not very user-friendly, and not something you'd want your self-service users to do. Another reason you might want to have that relational serving layer there is some people want to write SQL queries. Some people don't want to use Power BI to do all their analysis. They just want to write a good old SQL query. And then finally, if you've got really large data volumes, which some people have in their data lakehouses, you might need to use Power BI in direct query mode because you've got too much data to import into an import mode data set. The problem is here, you can't use Power BI in direct query mode on top of files. You've got to use it on top of a relational database, which is why you end up having that relational serving layer. So there are a couple of different reasons why you end up having to have that relational serving layer if you want to use Power BI. But it's not ideal. People don't like having it there because it's yet another layer in your architecture. It's something you've got to maintain. It's expensive because it costs money to have these relational serving layers running even for just part of the time. And yeah, it can add some latency because you've got to copy your data from the lake into the relational serving layer, and then typically if you're using import mode, you'll be copying it over to Power BI. So that moving data takes time. You end up with multiple copies of the data, which isn't great either. So even though that architecture I showed you earlier is very, very typical of people using Power BI on top of a data lake or data lakehouse, people really do not like that relational serving layer, and they really want to get rid of it. Enter Fabric. All right. This is a Power BI user group. And at this point, you might be saying, well, a Power BI person, I've heard about Fabric, but it's not really something that's going to kind of change my life. It's important to have an explanation of what Fabric is. Now, you might have already seen lots of presentations about Fabric and still thought, well, this isn't for me. But what I want to do is explain quickly what Fabric is, and not only why it's relevant for this presentation, but why it's relevant for a Power BI user group. A good way of thinking about what Fabric is to make a comparison. When I try to explain what Fabric is to Power BI, I always say Power BI is to Fabric as Excel is to Office 365. If there are some older people around on this call, maybe as old as me, you might be able to remember when Microsoft sold Excel and Word and all of the other different Office products as separate things, not as Office. They were just standalone products. And if you wanted a spreadsheet, you went and bought Excel. If you wanted a word processor, you went and bought Word. At some point, somebody very clever inside Microsoft said, we're selling Excel and Word and Access and PowerPoint and all of these things to the same type of people, to information workers. So rather than them having to go away and buy standalone products and then kind of work out how to copy and paste from a spreadsheet into a Word document and things like that, why don't we make all of these different products part of a big bundle, which we'll call Office, and then we'll sell Office, and then you don't need to go and buy these standalone products. And what's more, you don't need to go away and ever think about buying competing products. You don't need to go and think about buying Lotus 123 or WordPerfect or something like that. So we had this bundle of tools called Office. You bought it as one thing, which was convenient for companies. And then also from a technical point of view, there was some integration as well. If you open up Excel and you look at the ribbon there, you probably think, well, yeah, this is very familiar to the ribbon that I see in Word and in PowerPoint. So if you know how to use one tool, you know kind of how to use all of them. The UIs are familiar. And what's more, there's a lot of shared code underneath there as well, especially in the Office cloud products, where it's all part of one big platform. And that's the point to make with Power BI and Fabric. Power BI and Fabric are not two separate things. Power BI is not being replaced by Fabric. Power BI is like Excel, and Fabric is like Office, or Microsoft 365 as we should call it now. Because really, if you think about Power BI today, where you've got the Power BI service, and in the Power BI service, you can build reports, you can have dashboards, you can have paginated reports, you can have Excel workbooks. With Fabric, all you've really got is the Power BI service with some extra stuff in it. Fabric is Power BI. It's built on the Power BI service, and it's not something extra. If you've got Power BI today, you're going to have Fabric tomorrow. It is really just the Power BI service with some extra features and functionality in. Not just reports and dashboards and paginated reports and data sets, but machine learning and a fully featured SQL relational warehouse and notebooks and real-time analytics and all kinds of other stuff. So hopefully that excuses why I'm talking about Fabric at a Power BI user group, because Fabric is Power BI. And if you've got Power BI today, you will have Fabric, whether you like it or not. So how can you use Fabric to solve this data lake problem? Now, this is where we can start to talk about some Fabric features and some new things. First of all, let's think about what you can do if you've got an existing fully functioning data lakehouse. There are a couple of different ways you can solve the Power BI problem with an existing lakehouse. And the kind of first easy way of solving the problem, and perhaps the first thing that springs to mind to anybody who starts checking out Fabric if they've got an existing lakehouse, is to use something called shortcuts. Now, this is where we need to start learning a little bit about Fabric and some of the features of Fabric. One of the new things inside Fabric, one of those things that's been added to Power BI is a lakehouse object. You can go to the Power BI service, turn on your Fabric trial, and create lots of new things. And perhaps the most important new thing you can create is something called a lakehouse. A lakehouse is the center of the universe in Fabric. It's where all of your data gets stored. And all of your data gets stored in a lakehouse in one of two formats. It can either be in raw files of whatever type you want, or it can be in a more structured format called Delta. So Delta is an open source format for storing data in data lakehouses. And it's something, as with the data lakehouse concept, that was pioneered by Databricks. So if you're already using Databricks today, you probably already have a lot of data stored in Delta format. And if you've got data that's already stored in Delta formats, well, you can work with that data in Fabric without ever having to copy it in. You can create something called a shortcut to that data. So a shortcut inside a Fabric lakehouse is literally just a link or a reference to some data that lives somewhere else. And if you've got your gold layer in your data lakehouse in Databricks in Delta format, you can just create a shortcut to an existing table and then start working with it. So what do I mean by this? Let's start to do a demo. So here is a workspace. This is a Power BI workspace, a Fabric workspace, they're the same thing. This is a public tenant, so what I'm showing here is available today. And I've got my Fabric trial turned on. And I've created a lakehouse. So here is a lakehouse called Demo 1. And it has nothing in it. You will see inside my lakehouse, I've got two sections, tables and files. Files are where kind of unstructured data lives. Tables is where Delta data lives. Now, I can copy data into a lakehouse and store it there. But like I said, if I don't want to do that, if I've already got an existing lakehouse, what I can do is create a shortcut. So I click on tables, go to new shortcut. And there are a couple of different types of shortcut that I can create. I'm going to create a shortcut to ADLS Gen 2 storage. If I've got my data in Amazon S3, I will be able to do that as well. But let's create a shortcut to ADLS Gen 2 storage. I need to tell Fabric where my data is. I've already created a connection before, so I don't have to do any authentication. Click next. And then I need to put in a subpath that points to my data. And I'm going to call this OBT sales, because what I've got here is a single Delta table, which contains some sales information. I click create. It's going to go away and think about it a little bit. Hopefully this works. There we go. And I've now got a table appearing in my lakehouse. Remember, I haven't actually copied the data into my lakehouse. I've just created a link, a shortcut, a reference to the data that's already stored in ADLS Gen 2. And if I click on this, I can preview the data. You might be wondering what OBT stands for. OBT stands for one big table. One big table is a kind of popular modeling approach where you put all of your data in one big table. So what I've got here is a mixture of facts data and dimension table data. I've got, sales and tax and profit, which are measures. And then I've got some date information and I've got some product related information. Now, having done this, I can just go away and build a report. I'm going to go to the SQL endpoints. I'll talk a little bit about what this is in a moment. But having done this, I can just click, well, let's wait for it to load first. You can see the same data. I'm just going to click New Report. My Power BI report opens, and let's just create a bar chart. And I don't know, let's put products on here. And we'll put sales on here. And there we go. I've built a report. I didn't have to import any data. I didn't have to design a data set because it was just one table. And I didn't actually copy any data into Power BI or Fabric. How's this possible? Is this the magic solution that we've all been looking for? Well, yes and no, maybe. What actually happened here? As I said, I didn't copy any data in. I just created a shortcut to an existing Delta table in ADLS Gen 2 storage. And this, I think, is going to be the easiest solution to building Power BI reports on existing lakehouses. But there are some shortcomings here. And to understand the kind of big potential problem with this, we've got to understand the difference between what happens when you use a shortcut like this and when you actually start copying your data into Fabric. Because as well as using shortcuts, you can actually physically copy data into Fabric and store your Delta tables inside a lakehouse. Now, why would you do this? Well, let's say that you want to keep your existing bronze and silver layers in your existing lakehouse, and then you replace your gold layer with a gold layer in Fabric, which involves copying data into Fabric, doing whatever transformations you need to do at the gold layer, and then actually storing the Delta tables in a lakehouse rather than ADLS Gen 2 or wherever you're storing your data today. Why would you do that? Why would you go to that extra effort when I've already showed you that things just work anyway? Well, something called V-order. What I just showed you in that last demo was Power BI working in something called direct lake mode, which we'll talk about more in just a moment. But there is a difference, or there's some extra secret sauce that we at Microsoft add when you copy data into a lakehouse and store your data in Delta format in your lakehouse. And this is something called V-order. It's very, very important to note that when you copy data into a lakehouse and you create your Delta tables there, these are just regular Delta tables. They are Delta tables that follow the open source format. They are readable by other tools. There's no special changes to the format. It's still regular Delta. But Delta is based on Parquet, which is another open source format. And not all Parquet files are created equally. When you create a Parquet file, you've got to make sure the data in that file is compressed as efficiently as possible. And what we've got at Microsoft when we create our Delta tables and the underlying Parquet files is that we've got some special algorithms that we call V-order, which mean that our Delta tables are generally not only a lot smaller and better compressed than anybody else's, but they are also in a format that's going to make them work a lot better with Power BI and the other things that happen downstream later on. If you think about Power BI in import mode, and you've ever imported large amounts of data into Power BI, you will know that Power BI has always been very, very good at compressing data. You can connect to some gigantic text file import it into Power BI, and your PBIX file is actually surprisingly small because the data's been compressed so much. And we've spent years and years and years perfecting those algorithms for compressing data. And effectively, what we've done with Fabric is taken those same algorithms and put them into the code that generates the Parquet files and the Delta tables that you create when you copy the data into a lakehouse. And it's those algorithms that we call V-order. And it's those algorithms, the same algorithms that are used in Power BI in import mode, that make our Delta tables so much smaller and so much more efficient for the other things that happen in Fabric. And this means that there is going to be an advantage to copying data into a lakehouse rather than just creating shortcuts in the way that I've just shown you. Creating shortcuts works. I've just shown you it just works. And for most cases, it'll be fine. But if you get larger, if you start working with larger and larger data volumes, what you will find is that the performance of shortcuts may not be as good as if you copied the data into a lakehouse and used our own kind of V-order powered Delta tables. This then leads on to the question of how should I load data into a lakehouse using Fabric, and how can I model data? Well, if we think about data loading first, we've got a couple of different new workloads available in Fabric to handle that. A lot of them are actually not all that new for people who are used to working with Azure and Azure data services. For example, in Fabric now we have something called pipelines, which are a slightly stripped down version of Azure Data Factory. So if you're used to working with Azure Data Factory, you'll be familiar with pipelines. They're great for just copying data, and they're also great for orchestrating tasks. If you are a Power BI person, you'll probably want to check out Dataflows Gen 2. So if you're used to working with Power BI data flows, Dataflows Gen 2 are, as the name suggests, just the next version of Dataflows. There are two big changes in Dataflows Gen 2. First of all, we've kind of rewritten them to make them a bit more scalable. Data flows in Power BI today are great up to, for example, a couple of million rows, depending on the transformations you're doing, but then they can get a little bit slow. Data flows Gen 2 will be a lot faster when they're finished. And also, data flows Gen 1 today in Power BI are actually two things. They're ETL and they're also storage. You know, when you run a data flow, a refresher data flow, you can do your transformations, and then the output of that data gets stored in some hidden storage inside the Power BI service. And then when you use Power BI to connect to a data flow, you connect to that kind of stored data, the output of the data flow. With data flows Gen 2, you just have an ETL tool. You don't have that hidden storage anyway, because data flows Gen 2 give you the ability to load data to a number of different destinations. You can load data to a lakehouse. You can load data to Azure SQL DB. You can load data to a SQL warehouse inside Fabric. So you've got lots of options about where you want to load data to with data flows Gen 2. We have something called a warehouse. Warehouses are the successor to Synapse dedicated pools and also Synapse serverless. If you want to do your ETL in SQL, well, you can load the data using a warehouse and do your transformations using stored procedures, if that's what you prefer. And finally, for people who like writing Python or Scala or R, you've got notebooks. You've got Spark inside Fabric. So great for all of those kind of data engineers who prefer writing that kind of code rather than writing SQL. Let's have a look at what I've done here. If we forget about this report and go back to my workspace, what I've got is a Dataflow Gen 2. And rather than connecting to an existing Delta table, I've used this to connect to some CSV files in ADLS Gen 2 storage. Let's pretend this is my silver layer. And, I've connected to that, perhaps created some transformations. I haven't actually done so here. And you will notice that with a Dataflow Gen 2, it's grayed out because I've already set a data destination. But if I go to here and go through the wizard to show you what it's like to connect to a data destination, here I'm going to copy my data into a lakehouse. I can control which lakehouse it goes into. It's going to go into a table called date. I can load into any lakehouse inside my tenant I've got access to. And another nice thing is I've got now this opportunity to choose whether I replace the data in my existing table or append to it, which I think is rather cool. So I've got a nice familiar Power Query powered experience for loading data into my lakehouse. Nope. I'm going to exit that without running it because I've already run it. And then if I go to another lakehouse I've got here called sales, there are 3 of the 4 tables that I showed you inside the Dataflow Gen 2, date, product, and sales. And I can preview the data and see what the data looks like. It's the same data that I used in the other demo, but modeled slightly differently. Because this is the other point to make. It's not enough always just to copy the data. If you've got an existing gold layer, you might have your data modeled using that one big table approach. But Power BI doesn't really like the one big table approach. It will work, as I just showed you. But the really important thing that every Power BI developer should know, which is exactly the same when you're working with Lakehouses and when you're working with Fabric, repeat after me, Power BI loves star schemas. So when you're copying data into your lakehouse, not only should you be copying the data physically in to get the benefit of V ordering, you should be potentially remodeling it as a star schema because Power BI works best with star schemas. And a lot of people in their gold layers don't have that today because other inferior BI tools can't really work with star schemas in the way that Power BI can. But Power BI really needs a star schema. So possibility is you might need to do some extra transformation work when you're copying your data into your lakehouse. Okay, so we've established that it's going to be better to load our data and copy our data into our lakehouse because you get the benefit of V-ordering and because you may need to do some remodeling. The next thing to look at is something called direct lake mode. In that first demo that I did, I created a shortcut and I could just build a Power BI report directly on top of that without doing anything else. And the reason I was able to do this is because of this new thing in Fabric called direct lake mode for Power BI. And this, I think, is the most exciting thing in the whole of Fabric. This is the key innovation for Fabric. And I think this is the one of the main selling points, one of the main reasons you might want to use it. I would imagine pretty much everybody here who comes to a Power BI user group will know that up till Fabric, there were 2 fundamental ways of working with data. You had import mode and you had direct query mode, and they both had their advantages and disadvantages. With import mode, when you're creating your Power BI datasets, you connect to your data source and you copy your data into your dataset. And then when your Power BI report runs, it generates DAX queries. The DAX queries go back to the dataset. The dataset stores the data in the Vertipack engine, the kind of in-memory column store database engine that Power BI import mode uses. That answers the queries and the data goes back to the report. The other option is direct query mode. In direct query mode, you still build a Power BI dataset, but you don't copy any data into it. So when your Power BI report runs, it runs DAX queries against the dataset. The dataset then translates these back into queries against your data source, which 98% of the time is likely to be one that speaks SQL. So the dataset will be generating one or more SQL queries to get the data it needs. The data source answers the SQL query, returns the data back to the dataset. That turns it back into a DAX result set, which goes back to the report, which gets displayed. What are the benefits and disadvantages of each approach? Well, import mode is the default for a good reason, because it gives you the fastest performance for your reports. There are two big disadvantages to import mode, though. First of all, you've got to copy the data into your data set, and that can be slow. It can take quite a long time. And when the data changes, you've got to refresh it again. The second is that with import mode datasets, you're limited by size. You can't just load as much data as you want in, because there's a limit to how much data you can store in memory. And so as a result, depending on whether you're using Pro or Premium or which premium capacity size you're using, well, then you've got to, you're only allowed to import a certain amount of data for each of those. With direct query mode, you don't have data refresh because the data doesn't get copied into the data set. So you don't have any of these problems. The big disadvantage of direct query mode, and this is the big disadvantage, query performance is often a lot slower. That's because Power BI's Vertipack engine is incredibly fast and can handle a large number of concurrent users, unlike a lot of cloud data warehouses. And secondly, there's always going to be that latency, that kind of extra level of complexity caused by the dataset having to convert the DAX query into one or more SQL queries and then get the result back. So, two different approaches. With Fabric, you have a third storage mode called direct lake mode. With direct lake mode, when you copy your data into a lakehouse and store that data in Delta format, what you can do is have a data set that gets the data on demand from that lakehouse. Now, what does this really mean? Well, let's say that you've got your data copied into your lakehouse, like I've already got, and you've got your Power BI data set. When you build a report and the report runs, the report still generates a DAX query going back to the data set. But now the data set doesn't hold any data. What the data set does is go to the lakehouse and it imports just the data that it needs from the files in the lakehouse. So it is kind of a little bit like import mode, except that it only imports the data that it needs, and it does so on demand. And it's able to do so really, really quickly in, maybe a matter of kind of less than a second. And that's because with the data stored in a lakehouse in Delta format, that Delta format uses Parquet under the covers, which is a column store database format, which is very, very, very similar to the column store format that the Vertipack engine inside Power BI uses. So instead of having to spend a really long time importing data, what the clever people on the Power BI team have worked out is that you can actually import just the data you need on demand from a Delta table in a lakehouse really, really quickly and get the performance of import mode without having to do any refresh, because you just import the data you need on demand. Now, direct lake mode is not going to be as fast as import mode, but it is still pretty fast, and it's going to be faster probably than direct query mode. Any performance overhead is likely to be when you've got a cold cache and the data is not already stored in memory. But after the data has been moved into memory after that first query, the performance is going to be about the same as import mode. But like I said, there's no refresh and you get pretty fast query performance, which is great. So direct lake mode is like the best of both worlds. It's like the best of import mode and the best of direct query mode. So let's see this. Let's go back to here. Here is my lakehouse. I've got my 3 delta tables, date, product, and sales. If I go and look over here, calling this a SQL endpoint, I think, is a little bit misleading. It is a SQL endpoint, but it's a lot more. Because if I go to the model view here, well, what do we see but a Power BI dataset designer, the web editing experience? I've got my sales table, I've got my date and product dimension. The only thing I had to do here was define the relationships between these 3 tables. So very, very nice and quick. And once again, I'm going to repeat that demo of creating a new report. But this time, let's understand what's happening here. So there is no data stored in memory in that direct lake dataset that I just showed you. If I was to drag product into the y-axis and then drag sales, I've got a measure here, and drag that onto the x-axis. Each time with those 2 clicks, a DAX query was sent from the report back to the dataset. And then on demand, what the dataset did was grab just the data it needed from those delta tables and load the data into memory and then run the query. Which now means, if I was to drag color in there, that column has just been loaded into memory. Let's turn it into a slicer. I don't need to load it into memory anymore because it's already there in the cache. If I slice and dice, I'm working now on data that's already stored in memory. So it's pretty fast. This is a small amount of data, but even if you test it with quite large amounts of data, we think you're going to be very surprised at how good the performance is. So that's direct lake mode. And direct lake mode is really, really cool. But you also get some other benefits. With the data now stored in Delta inside your lakehouse, you don't only get to query it with Power BI, you can also run SQL queries against it. And you can write code. You can use Python or R to get at the data if you need. So let's see an example of this. Well, let's forget that report and go back to the SQL endpoint of my lakehouse. It's called the SQL endpoint because I can write SQL queries here. I could write a SQL query if I want. Let's say select star from product and run it. There we go. I've got some queries saved here. There we go. I've also got something quite nice from a Power BI person's point of view. What's this? It's our old friend Power Query again. And in this case, I'm using Power Query to build up what effectively is SQL queries. If I view SQL here, there's the SQL query that's being generated for that. And I can just turn that into a SQL query. So I can use Power Query to generate SQL queries if I want. So that's really cool. And with the data stored here, I can use Python, for example. So I can use Spark SQL to get the data into a data frame, and then I can write some code and aggregate that up and get the sales by month. Incidentally, if I don't like writing code, well, I don't need to write code. The code here was generated by a tool called Data Wrangler, which again is, a kind of self-service tool that generates Python code, which I think is really cool. So you get SQL querying and the ability to analyze data in Python or R from exactly the same data, the exact same files when you copy the data in, which is really cool. One more thing about this, going back to shortcuts. In the very first demo here, I created a shortcut to a delta table stored in ADLS Gen 2. What I can also do is create shortcuts to data that's already stored in Fabric, but stored in different lakehouses. I can have as many lakehouses as I want inside a workspace, and there could be other workspaces with other lakehouses in. And those lakehouses may contain tables that I want to be able to use. And shortcuts will allow me to reach out and get references, to link directly to these tables in other lakehouses, which I think is going to be really, really useful. Let's see an example of this, because it's something that I think has to be shown rather than explained. Now, if we go back to the sales lakehouse, we've got our 3 dimension tables: date, product, and sales. And I was able to kind of model them like this. Now, let's say that I want to be able to categorize my products somehow. If we have a look at the product table, you can see that we've got some different types of fruit, and they are in a category. I've got a category ID, but nothing else. So in another lakehouse somewhere, I've got a category dimension table. Instead of having to copy that category dimension table into this lakehouse and have another copy of it, I can just simply go to, let's go to the lakehouse, create a new shortcut, but create a shortcut to a table already here. And I'm going to go to product categories, click next, find my product category table that's stored in a different lakehouse, create a shortcut to it. And even though I'm not actually copying the data into my lakehouse, it still stays in the lakehouse where it originally was. I can still see the data in it, and I can use it inside my direct lake dataset. So we'll give it a chance to warm up. There's the table. And if I go to my model, there's my product category table. And let's drag category ID onto here. There's the relationship. And again, let's build a new report. And let's get product category and sales. And there's our data. And remember, I have not copied that product category table at all. I just created a shortcut to it. Why is this useful? Why is this important? Well, everybody today using Power BI knows that the one important thing that you need is a date dimension table. Everybody needs a date dimension table in their Power BI dataset. Now, you might have a single copy of that date dimension table inside, your data warehouse or whatever you're getting the data from. But if you're using import mode today with Power BI, think how many times your data sets, whenever they refresh, connect to that date table and copy the data in. And think how many times that date table gets refreshed. It's going to be small, so copying the data doesn't really matter that much. And it's going to be fast to refresh. But think how many times and how many different copies of that same data are stored in data sets around your organization. Think how much time you spend refreshing just date dimension tables. And then think about all of the other dimension tables that are going to be copied. Maybe you've got multiple data sets that all need a product dimension table. Maybe you've got multiple data sets that all reuse the same fact tables. With import mode, you are creating multiple copies of this data and multiple copies that need to be refreshed. So there's an overhead with refreshing. With direct lake mode and using shortcuts, you bring your dimension, your fact tables into lakehouses once, and then you can have as many data sets as you want that use these tables and use the single copy of those tables. So you don't have to refresh more than once. You don't have to move the data around. You can create data sets kind of like Lego. You just, link up tables that are already there and then build your star schemes. And I think this is a really, really powerful thing. One that's going to save people a lot of time and also a lot of compute as well. Last thing to talk about is something that I can't demo, but I think something that'll be really, really useful. And this is something called One Security. Now, today, if you're using Fabric, and today, if you're doing anything in a data lake, you'll know that you have your files, your data stored in your data lake, but if you want to apply security to it, there can be a little bit of a problem. Because you can apply security in your relational serving layer, but if you're reporting your data into Power BI and you want to apply, say, row-level security, well, you'll have row-level security defined in the relational serving layer, and you'll have the same security rules kind of duplicated in your Power BI dataset, which isn't great because, again, you've got two copies of the data, two copies of the security, and what happens if they aren't quite in sync. So extra effort, extra problems with having to keep everything in sync. With OneLake coming soon, what you'll be able to do is define your security once on the Lakehouse. You'll be able to define table level security, row level security, column level security, and eventually data masking. And when one security is finished, that same security defined once will apply to SQL queries that you run. It'll apply when you're writing Python in a notebook. It will apply in your Power BI direct lake datasets. So you define the security once, and every single Fabric workload respects that, which I think is an incredibly powerful thing and something that a lot of customers will love. So, in summary, what have we learned today? First of all, don't be scared of Fabric. Fabric is just Power BI with new stuff in it. If you've got Power BI today, you will get Fabric. It's not something that you will have to ask somebody to get. You'll get it anyway. Fabric solves a lot of the big problems that people have today with building Power BI reporting on existing lakehouses. It will be easier, it will be faster, and it will be cheaper. So, we would like to say, if you've got a lakehouse today, Fabric is going to be the answer to your prayers. Even if you don't have a lakehouse, there are so many things that are really cool in Fabric. You might choose to start using Fabric to build a lakehouse anyway, even if you haven't got one, just to get all of that cool stuff. And finally, if you've got Power BI today, you can spin up a Fabric trial capacity for free. So if you want to test all of this stuff out and you've got Power BI at home, you don't need to pay anything. You just set up a free Fabric trial. That will be free until GA. And then after that, the trials will be limited to 60 days. So you can start to go away and play with all of this and start learning it. So that's me done. I think there are some questions in the chat. So let's take some time to answer some questions. I can see the questions in Teams. I can't see the questions in YouTube. I guess there are probably questions in YouTube as well.
Yeah. I'll go through with this question later on, Chris. So let's first start with the Teams questions. So just a minute. Let me just. So the first question is from Rajendra. How does one copy data in Fabric be different from an existing warehouse data? That's the
So,
first question.
so when you copy data into Fabric, into a lakehouse, the data is stored as files. The storage that Fabric uses is basically a layer built on ADLS Gen 2. So you're copying your data in. It does get stored as files in ADLS Gen 2, which you can get access to using all of ADLS Gen 2's existing APIs and interfaces. If you're copying data into a warehouse today, you're copying it into a relational database engine, which might store some data in a format on disk behind the scenes, but that's not something you get access to. The only way to get access to data in a warehouse is to run SQL queries, whereas with Fabric and OneLake, you're storing your data in Delta format, which is a kind of open standard, which means that anybody using any tool that can connect to Delta tables can get hold of that data. So, if you want to use Databricks to connect to data stored in OneLake, you can do that.
Okay. Thanks, Chris, for the answer. Hope Rajendra, you get your answer. Maybe you can just add your reaction in the chat window. Second question we have from Imtiaz. Imtiaz has two or three questions over here in the chat window. Imtiaz, we just provided you the mic access. Can you directly ask the question if you can?
Sure. Well, hi, hi, Chris.
Hi there.
Hi. So you know what? I have a couple of questions. The very first thing is, of course, see, we have been writing SQL queries. Of course, we have Python, R integration as well. But do we have? I'm sure we would be kind of having that functionality. How about accessing stored procedures, right? Because we have lot of complex stored proc. So if at all we have to go for any complex SQL or complex queries, will it kind of be useful here, right? Within the Fabric environment.
Yes. So with Fabric, when you load data into a lakehouse, like I said, the data in the lakehouse is stored in Delta format, but the lakehouse has automatically this SQL endpoint that's created. And that allows you to run SQL queries to query the data, but that's read-only. If you want to use stored procedures and things to transform your data, you have to spin up a warehouse.
Okay.
Now, a warehouse in Fabric is, like I said, it's kind of the successor to Synapse dedicated pools or Synapse serverless, but it is just one thing. It's our new kind of high performance relational warehouse engine. That allows you to not only read data and query it in a lakehouse, but also write data back to the lakehouse. So you can use stored procedures, use T-SQL. It's not full T-SQL. There are going to be some limitations about what you can and can't do, but it's T-SQL, so you'll be able to write your stored procedures and carry on transforming data in the same way.
So basically, we are saying that we'll have to write pipelines, we'll have to create pipelines, and then execute that, and then store the data within the defined lakehouse, and then kind of have Power BI dashboards created on top of it.
Correct. Yes.
Okay. Of course, I have one question which is very important, related to structured and unstructured data. For instance, because this is one of the live situation that I've come across with. One of my team have been creating APIs using MuleSoft, right? And the output of that is kind of a JSON file, right? So what they were say they have been doing is like the MuleSoft is kind of creating the endpoints. That endpoints has been kind of been leveraged within the Azure landscape, right? And the same thing is kind of going into the lakehouse architecture. So the same thing, whether we will be able to perform the similar kind of operation within Fabric as well, or is it kind of a different kind of approach?
Yeah, you probably will. This is maybe getting outside my area of expertise, but I think this is somewhere where you'd probably want to write some Python code to call those APIs, bring the data into the lakehouse. But yeah, I'm probably not the best person to ask about this.
No issues, no issues. One last question. Sorry, Chris, I'm kind of bugging you with a lot of questions here.
That's all right.
But believe me, before asking that question, I really liked this session. Even I am from the tutor background. I've been kind of imparting a lot of sessions, but the way you have been imparting session was really great. I've seen
Thank you.
very less people, right? Okay. So from the open AI standpoint, right? I mean, this is not related to Fabric though. This is core Power BI related question. Um, I had a requirement where the user wanted to have the Chat GPT kind of environment being set up within Power BI. So what we did was we kind of used the Open AI API, and then we were able to kind of get the Chat GPT enabled. But we were just able to kind of send across only 5 questions. Is there any limitation, or we have to kind of get into the licensing? I mean, I don't know. That was one of the question.
Well, I mean, yes, that's something you're going to have to set up specially. There are going to be licensing issues here. There are going to be performance. There are also going to be data privacy issues here. What I would say is wait for Copilot to be available in Power BI. It is coming in the future. We're working really hard on it, and that I think should give you a lot of what you need.
Perfect. Thanks a lot, Chris. Thanks for the answers. Thank you,
No
Ranjan,
problem.
and thank you, Dhruvin, for providing the platform where I can ask the questions. Thank you, guys.
Thank you so
I'll
much.
go on
Thank you
mute.
so much. Yeah, no worries. Next, Abhinav, do you have you posted one question in the chat window? Do you want to ask directly to Chris?
Thanks for joining. Thanks, Chris, for joining today. This question is about with respect to the storage in terms of Chris, AS being hosted within Power BI Fabric, or being connecting to OneLake storage directly. So how does Direct Lake storage compare with AS in terms of performance? What's the guide, and also what's the guidance around it? That's something we have been exploring.
Yeah, this is a really, really good question. The first thing I would say is that Fabric's in preview. So we are still working really hard to improve the performance of Direct Lake. Generally speaking, if you're thinking about a cold cache, so no data stored in memory, the first time you run a query against an import dataset after it's been refreshed, the first time you run a query against a direct lake dataset after the data's just been loaded, we would say the performance. I mean, I've seen figures that where an import dataset is perhaps the cold cache performance is maybe about 2/3 of the duration of a direct lake dataset. So it's not an even thing, and the difference will be less depending on how much data the difference will vary depending on how much data you've got, how you structure your data, the type of queries that are running. But generally, direct lake storage is a bit slower, but not that slow. It's usable. It's usably slow, usably fast. So not really, really slow. But perhaps noticeably, there might be 1 or 2 seconds delay on those first few queries compared to import mode. But then after that, as soon as the data's been kind of loaded on demand into memory, the performance is about the same. Again, direct lake mode might be a little bit slower, but we find that even if direct lake mode is slower than import mode, the fact you don't need to do any refreshes is a big thing. Now, it's a little bit dishonest to say you don't need to do any refreshes, because you still need to copy the data into Delta, and vOrder does add a bit of overhead into building those Delta tables. But if for people who've done testing and compare the kind of end-to-end performance, if you're already building a gold layer with Delta tables, then doing it in Fabric and having vOrder turned on doesn't really add too much time. And then Direct Lake just works after that. So you really do get a big advantage of much, much faster kind of end-to-end ETL. And then the performance of the reports is still pretty good. It's going to get better. Direct Lake is going to improve, but already today it is impressively fast.
Sure. Thanks much, Chris.
All right. We have next thing from Kumar. You want to unmute yourself and ask?
Yeah, sure. So when I was using Direct Lake as a part of import, I found there was no way to reorganize the measures like we do into Power BI desktop. That's the first thing. I was also not able to create calculated columns at that point, Chris. So is there a way I can do them or
Yeah,
wait
so
for GA?
calculated columns aren't supported yet. They may be supported in the future. The key thing is with direct lake mode, because of the way direct lake mode works, calculated columns can't be created because the Power BI is loading the data from the delta
Yep.
tables, which is its copy of the data. Now, maybe that will change in the future. I don't want to make any promises, but if you want to create calculated columns, you need to create them further upstream in your ETL, however you're loading your data in. So it's kind of a bit like direct query in that you need to have your data properly modeled in your lakehouse before you build your data set. You can't, kind of add extra columns and things, which I know is a bit of a pain. But we'll kind of see what happens in the future. Organizing measures, well, if you want to create folders or a measures table or something, it's not ideal. Partly this is a limitation of the web editing UI, but you can use something like tabular editor on direct lake mode datasets now. The real problem if you were creating a measures table is that with direct lake modes at the moment, a dataset can only, if you want to use direct lake mode, a dataset can only contain direct lake tables. It can't contain import mode tables or anything else, which then turns into a bit of a limitation. You can't create a dummy table in import mode and put your measures on there because that's an import mode table and we don't support that yet. That's a limitation that we're going to be working on removing in the future. I don't want to say by GA because because with Power BI, we GA for anything didn't really mean much because we were always continuously improving things, and that's going to be the same with Fabric.
Yep, all good. So I think we are covering with all the questions, and today's session was really interesting, Chris. I think we have seen first time on working day 100+ audience in our live, and more and more people join in the teams as well, and this question itself proves that the session was really interesting. So thanks a lot for this wonderful presentation, and we are really looking forward for your session in some upcoming month and upcoming events as well.
Right.
Thanks a lot.
Thanks much, Chris.
Thanks a lot.
To be on this journey from OLAP to Fabric now.
I'm glad somebody's old enough to be able to remember all of that stuff as well. Cool. Thank you then.
All right. Thank you so much, everyone. Have a great day ahead. Goodbye.
Thanks.
Bye-bye.